Okay, so this section, after we've done a couple of sections on exponential functions, we're going to turn to logarithm functions. And so logarithms are just the inverse of an exponent. Um, and so a lot of this stuff I think will be easier to understand if you kind of conceptually understand it and just kind of know how to calculate a logarithm, for example. I think it's especially with the graphs, it's a lot easier if you can think of these in terms of being inverses of exponents. Um, so let's kind of introduce this. Every exponential function, a to the x, is a one-to-one function. So here we have the exponential function where a is greater than one. Of course, we talked about the ones where a is less than one, between 0 and 1, and that one comes down like this. But same thing will apply. So this passes a horizontal line test, which means it's one-to-one, and which means has an inverse. And so the inverse of this exponential function is called a logarithmic function. Um, with the exponential function, we have the base a. The logarithmic function that would be the inverse of this one will also have base a, and it's denoted by log with the subscript a like that. So if a is any positive number not equal to 1, the logarithmic function with base a is denoted by that. It's defined y equals log base a of x, and it's the inverse of a to the y equals x. And so this is actually a very important relationship that you want to make sure that you understand. Um, and we could say log base a of x is the exponent to which the base a must be raised to give x. And so essentially what you can think of it, if you substitute, so y equals log base a of x, if you substitute that in for that y right there, you'd have a to the log base a of x, and they would essentially cancel each other out because they are inverses. Um, and so we see this relationship here. We're going to look at some in a minute where we have to convert between the logarithmic form and the exponential form. And so we can see this relationship here. The base of the log is the base in the exponential form. And then the exponent in the exponential form is the answer, I guess you could say, in the log form. And so kind of the way I think about it when I'm working through these, uh, the base is the base. The base is the same. And then these two numbers will just switch sides on the equal sign. So in the log, the x is on the same side as the base, and on the exponential, the y is on the same side as the base. So ever, it's just kind of a way to remember it. I wouldn't exactly call that a mathematical, you know, statement or anything, but that's just a way to remember it. Um, So the logarithmic and exponential forms are equivalent equations. If one is true, then so is the other. And so these are equivalent forms. So one is true and the other is true. So log base 10 of 100,000 equals 5. And you could almost say because 10 to the fifth equals 100,000. That's how that would be found. Log base 2 of 8 equals 3 because 2 to the 3 equals 8. And so what I want you to make sure that you can kind of recognize and get used to seeing is how do you go from this form to that form? And if you can do that, when you see just log base 2 of 1/8, for example, you would without this, what does that equal? You would know it equals 3 because 2 to the negative third is 1/8. Um, so we'll work through a little bit of this here. Convert the following to exponential form. So we have log base 10 of 1,000 equals 3. So in exponential form, the base is the base of the exponential form. And then these two are going to switch sides. So the 1,000 was on the same side as the 10. The 1,000 is going to move to the other side. And then the 3 is going to move also to the other side. So 10 to the third equals 1,000. And of course, we know this is true. Um, and so it must be, in other words, the reason I say that, because if you rearrange these numbers in any other way, say 3 to the 10th equals 1,000, we know that's not true. 3 to the 1,000 equals 10. Obviously, that's not true. Or just rearranging these numbers, that's the only way to get an exponential form of these three numbers in a correct way. So um, that helps. And yeah, if you have one of these, like you could memorize this and you know that that would be true, and then it helps to go with other problems. So if you have a pattern to follow, it helps with other problems. So this one we have log base 2 of 32 equals 5. So 2 is the base, and then 32 and 5 are going to switch sides. So 2 to the 5th equals 32, which of course you can easily know that's true. All right, now we're going to go the other way. So we're going to convert these to a log. So what is the base? The base is the base of the exponent. And then again, these two are going to switch sides. So we have log base 3 of 243 equals 5. Here we have log base 16, and then the 4 and the 1/2 are going to switch. Okay, so you want to make sure you can do that fairly easily. And before I forget, let's talk about this just in case this comes up. How would you put this in the calculator? So most calculators only work with a couple of bases that we'll talk about towards the end of the section. But if you want to do just any base, log base 3, if you want to put this in the calculator, log base 3 is log of 243 over log of 3. And so if you can put this in the calculator. Most calculators, you're not going to be able to put this in. So if you ever do have a weird uh, any base, whatever it is, you can kind of convert it to this form and then get the calculation. All right. So properties of logarithms. Oops. And so a lot of these you could kind of figure out, like if you convert this one to an exponential form, you'd have a to the 0 equals 1. Of course, that's true. So whatever you raise to the 0 equals 1. So the inverse of that would be log base a of 1 is always 0, no matter what the base is. Here we have log base a of a. As long as the base and the argument match, it's going to equal 1 because, of course, a to the first power equals a. And then these are basically just proving and showing that the log and the exponential are inverses of each other. If we convert this one to an exponential, we'd really just have a to the x equals a to the x. And then this one converted to a log, we'd have log base a of x equals log base a of x. And so those are really showing that they're inverses of each other. So use the properties to find the following. Log base 5 of 1 would equal 0 by property 1. Log base 5 to the 8th, that would equal 8 by property 3. Log base 5 of 5, that would equal 1 by property 2. And then 5 to the log base 5 of 12 would equal 12, and that's by property 4. So you want to be able to do those, be familiar with those. We'll learn some more properties in the next section. But again, it's a good idea to make sure that you are familiar with the concept. So don't just kind of expect to be able to put these things in the calculator and work these problems out. You need to be able to understand the relationship between these two things. So if you have any questions, you can email me and we'll answer those.